Welcome to the next lecture on design for assembly. As you know, in manufacturing there are two important processes. One is fabrication, the other one is assembly. And people slowly have started realizing that if you give more importance to assembly, then you will try to have more number of parts and there is a prone for defects also. So now people are looking for, can we make a product which is assembly free, or can we reduce the number of parts, make it into small sub assemblies. In each sub assembly you have very minimum parts, so that the assembly is perfect. And the other thing, companies have also started realizing that assembly process, if I do, nobody is going to pay me extra. So slowly the companies have started working on design for assembly and shifting the assembly process completely to the customer side. For example, when you buy a fan, ceiling fan, we buy it as parts and then we assemble it to get the final product. Today when you are looking for a modular kitchen, you buy it as parts and then you assemble. When you buy a desktop computer, you get it both version, assembled version and unassembled version. So you try to get everything and you start assembling it. So slowly, and for example, when you talk about modular furnitures, so that is the other thing which is also talked about. People are slowly started assembling the final product at the customer end rather than manufacturer's end. So design for assembly is the next topic. There is lot of importance now company is giving towards this to make their product more reliable, repeatable, and they take care of logistics costing also. So in this lecture we will go through design for assembly, then guidelines for different modes of assembly, then methods for evaluating design for assembly, then design for disassembly, assembly, disassembly process planning, disassembly sequence planning for a product with defective parts, and finally reasons for not implementing DFMA, design for manufacturing and assembly. What is assembly process? Assembly of a product is a function of design parameters that are both intensive and extensive in nature. Example of such design parameters include, but are not limited to, shape, size, material compatibility, flexibility and thermal conductivity. This is what is definition or the meaning for assembly process. Assembly of a product is a function of design parameters that are both intensive and extensive in nature. If you look at the complete assembly of a car, you see that the underbody is kept on a pallet and this is moving in a conveyor. And interestingly, in car assembly or in automobile assembly or in pizza assembly, wherever your mass production rate is very high, they look for automated assembly line. In automated assembly line, in order to maintain the production rate, they always move it on a conveyor. In this conveyor, you put a fixture and hold your part. So your part is here nothing but the underbody or a chassis of a car. So that is put on a pallet or a fixture. Now this is placed in a fixture and this moves at a regular speed. You can do two things, continuous feeding, or you can also have discrete conveyor moving speeds. So, when I say discrete, it comes and stands at a station and it stays in that station for a limited time and then it starts moving to the next one. So, when you do this, the entire cycle time of all these stations have to be balanced, both in terms of inventory and second in terms of the operations what is to be done. So, now you see the body side, one side, that is left side, and right side it is done. Interestingly, in car assembly what happens, the conveyor moves like this and you have a set of works happening in the left hand side as well as in the right hand side. So, you can have inventory here, you can have an operator here and you can have an operator here. So, he does all the right side work, he does all the left side work and the conveyor keeps moving all along. So, here if you see, this is the body side which is fixed to the underbody or the chassis, right. So, now it is done on both sides. So, then the conveyor keeps moving to the next stage wherein which it gets assembled on the spot welding or welding happens. Here it is only placing and the next station you can have welding operations. Moment the welding is done, so or the fixtures are put so that you can do all the fasteners and then it moves for the roof, for the bonnet and for the hood. So, you can these three parts come and get filled up, or here it is only roof and then the conveyor keeps moving to the next station wherein which you have deck lid which is put and you have the hood which comes on the top. So, hood comes here and then you have a lid, deck lid comes here, or this is called as dicky or deck lid. So, in a very colloquial term in India we always call it as dicky. So, dick lid is put here and then you have a hood here. So, this is assembled and now what you see is you see only the shell of the car, and then what they do is you have to now start feeding engine and other components. So, this can happen while the car is made or the entire wide body assembly can happen and then you start fixing the engine and other working functional parts inside and then comes your tire fixing and other things. So, this is a complete assembly line. If you look at the other way around, when you look at pizza corner or Pizza Hut, wherein which the assembly is all done at a single station and then it is passed through a furnace, okay, where this furnace it passes through, there is a time period and temperature heat. Time heat is set, it is passed through and then what you get is a final assembly of parts. You can have single station assembly, you can have multiple station assembly depending upon your products. And the beauty of assembly line is the cycle time for every process is tagged. And suppose if one station stops its production, the entire line stops its production because the conveyor cannot move to the next station with a defective part, or if there is a defect which is happening which you could not rectify and it is allowed to move, and what happens is all further operations on this defective car will not happen and the car will be exited out as defective or rework. This is also possible. If in case it is only one defect and it is peculiar which is not going to get continuously repeated, so then they say okay, let it go and then we will pull it out, rework only on the car, but the rest of the car let it go on the fresh one. Suppose if there is a major defect on the metal working operation, a hole is there or a dent is there, then the entire car is pulled out, reworked and then done, and rest of the assembly the car goes through every station, it spends that time and no work will happen on the car. What is disassembly? Disassembly is the organized process of taking apart a systematically assembled product. So, it is pretty interesting when you disassemble you should be very, very systematic. I remember when I was young, I dismantled a tape recorder. I dismantled it completely with the enthusiasm that I will be able to put it back. I did not realize that there are so many parts which have to go in the selective fashion. That means to say this screw can go only here, that screw can give left hand, it will go left hand, right hand has to go right hand. So, I did not realize the importance. I just removed all, put it in a piece of paper and kept it aside, and then started assembling it. Then I realized the problem. My father taught me the systematic way, and what you have to do is, you have to take a paper, you have to take a part, mark on the part L, on the paper whatever you do, keep that and mark it as L. So, then you place the part here, so that when you assemble it, it is done one after the other after the other. And in the same way, he also told me that you should have the system assembly. For example, if the subsystem assembly is S1, please write it as left hand side S1. So, this is a systematic way of dismantling it of a systematically assembled part. Dismantling process is also very important. Today you can see the tire in a car, when it gets flattened, the assembling and disassembling time has become very less. There are quick fastening nuts which have come into action. So, all these things are designed for disassembly process. The products may be disassembled to enable maintenance, enhance serviceability, to affect end of life objectives such as product reuse, remanufacture, recycle. So, many a times what happens, you might have a product. So, in this product I will section this product into several assemblies. So, S1, S2, S3, 4 and 5. So, if you look at it, so all these sub assemblies need not fail when the product is not functioning to the expectation. There might be only S4 a failure. So, one way of doing it is, you service it, replace this part and start using the same product. The other way around is, start dismantling, remove those parts or sub assemblies which are good, and then try to salvage it, put it into a next product and start using it. Okay. This is what we are calling it as reuse, right? Reuse. Recycling means you take it out, dismantle it, and then you try to generate the raw material, and from the raw material you process it to get the part. So, here the raw material is a material which is getting used, or which is available in the market, already in use, that is recycle. Remanufacturing is, what we do is, we try to change the part whatever it is there, cut it into pieces or do some modifications and then start using it. Okay. So, these are the three objectives. In fact, today when the product is sold in the market, some of the sub assemblies are given warranty 7 years, warranty 2 years, warranty 10 years, warranty 6 years, it is given. So, the overall product is given a warranty of 2 years, but individual sub assemblies are given warranty of different time. So, now the company says, if you come back within the warranty period and give me back all the sub assemblies to me, now on the new product I will give a discount and I will give you a fresh product, and the company tries to take these products for recycling or reuse. Okay. So, now the concept of assembling and disassembling is getting integrated heavily into costing also. So, when we talk about a sheet metal part, okay, so you can see here detect slot manufacture, slot parameters and issues, and then we look at this, we try to get those details. Then here it is all bend parameters and allowance, then hole parameters and allowance and distance between the holes and other features when we try to look at this part. And then multiple bends and manufacturing challenges. So, here if you see the entire part or maybe 1, 2, 3, 4, 5, 6 parts are now getting integrated into one single part, and this is done by metal forming. So, in metal forming, first they might do all blanking operations, then they might do all shearing operations, then they might do all bending operations to get whatever it is. So, this can be done progressively or this can be done in next stations, the fixture can move one station to the other. So, this is completely from the sheet metal point of view following design for assembly. So, you can see here multiple bends and manufacturing challenges. This part is completely bent in different things, and then cutoff and distance between features. So, this is also there, cutouts. Okay. Then here it is hem parameters. This is nothing but a bending parameter. So, wherein which we use it for insertion or fixing. So, you see design for assembly is used, number of parts are reduced, everything has got integrated into a single part. The other way around, what will be the alternative if I do not want to do it in a complex way? I try to manufacture all these parts and then I do welding operation and then I assemble it, which sometimes leads to a failure when one part gives off. So, when we talk about the definition, design for assembly seeks to simplify the product so that the cost of assembly is reduced. Consequently, applications of DFA principles to product design usually results in improved quality and reliability and a reduction in the production equipment and part inventory. For example, if you have a screw to be mounted onto a bolt, a screw or a bolt to be done to a nut, and this is going to be used for assembling some operations. If you want to, because if you see here, the fastening happens, okay, this fastening happens by one part, you need the second part and you need the third part. If I wanted to apply design for assembly and try to eliminate the parts, what I will do is I will eliminate these nuts and make the threads internally inside the part. So, now what happens, the bolt or whatever this part is getting fastened to this base without using the nut. So, you have reduced a part and this reduces the failure of the complete product. Okay. So, we can always think of making a thread along inside the hole and try to fix this part with this part directly rather than using a fastener. Okay. So, when we try to follow design for assembly, the results in improved quality, reliability and a reduction in the production equipment and part inventory. All these things leads to a efficient product. It has been repeatedly observed that these secondary benefits often outweigh the cost reduction in assembly. Cost reduction in assembly. So, we are trying to product is now getting improved and cost is getting reduced if you follow design for assembly. So, different methods of assembly, these are called as manual assembly. So, in manual assembly what happens, you can have a conveyor belt. This conveyor belt can be moving from station to station to station and people are involved in doing assembly. So, in fact, when the placing of parts and then they use the hydraulic ram to push the part inside or they just do assembly and do soldering along the assembly line. So, manual assembly, the operation is done by a manual or it is done by a man, okay. Operation is done by a man, but the conveyor keeps moving from station to station. Okay. So, it involves parts that are transformed to workbenches where the assembly of individual components into the final product takes place. Okay. Hand tools generally are used to aid the worker for ease assembly. That is what I said, you can use here a press, a small press to place the parts and then press it inside. If you want to have a shrink fit, you just do that and then try to get the output. Generally, washed assembly is done like that. If you want to do bearing assembly of very small bearings, they do it like that. Okay. And many of the ornamental works are done in this way, manual assembly line. This is a complete automatic assembly line. If you see in complete automatic assembly line, the first thing what they follow is they will follow unidirectional assembly. That means to say the part will be locked at the bottom end and rest of all parts which are to be assembled happens only in one direction from the top. And this makes the assembly very easy. This method uses either synchronous indexing machines and part feeders or non-synchronous machines where parts are handled by a free transfer device. So, synchronous indexing machine means the parts are fed by a feeder. It is not manually fed. So, you might have a chute, in that chute all the parts are loaded. So, the parts are dropped one after the other, it drops at the required place and then you can use a robo or robo to assemble, or you can do you can also try to use some other automatic devices to get it done. Non-synchronous machines are those where the cycle time for every operation is different. So, here you can feed the parts for free transfer and other things. So, this is automatic assembly. This is robotic assembly. So, this can take the form of a single robo or a multiple station robotic assembly cell with all activities simultaneously controlled and coordinated by a PLC. PLC is program logic controller. So, which tries to say, okay, first this operation to happen, that operation to happen, third operation, fourth operation, fifth operation, and if at all there is any problem in the first or second, it goes to an emergency stop, and then there you also try to do a sequencing with respect to time. So, I would say sequencing, and then it also have sequencing with respect to time. So, you can start doing it. So, this is a robotic assembly. So, the form of a single robo or multi-station robotic assembly cells with all activities simultaneously controlled and coordinated by PLC or computer. So, there are different methods of assembly on the basis of type, production volume and cost. We try to choose different methods, that is manual, robotic, automatic and other things. So, let us see how do you choose this. So, this is assembly cost per product. Okay. This is going to be the manual assembly. This is maintainability. This is how it is going to be for automatic assembly. And for robotic assembly, the cost is going to be something like this. This is going to be for robotic assembly. For manual, the constant cost. When you try to automate, it is going to the price is going to fall down drastically, and when you try to do robotic, if it is small parts, it is going to be expensive, and if the production rate is high, then the cost is once again going to go high. So, you have to see where is the break even point and then start choosing for automatic assembly or manual assembly or robotic assembly. So, in automatic assembly, synchronous, non-synchronous, robotics, PLC and computers are used for controlling, and manual assembly you use a human being to do it. So, if you look at this, the best parts are quality parts are got from automatic assembly only. So, let us see the assembly methods based on production range. This is the annual production volume. Okay. This is going to be the number of components. These are special purpose automatic assembly. Going to be 1 and this is going to be 5, and here this is going to be for 100, this is going to be for 200, and somewhere here it is going to be for 500. So, this is going to be manual assembly. If the annual production volume is in terms of 100, it is manual. So, we use 1 or 2 robotic arms for doing it when the annual production rate is somewhere close to 200, and when it is close to 500, we try to use multi-station with robotics. When the production rate is extremely high, we go for special purpose automatic machines. These machines are custom built for doing only those operations for a required part, or it is a customized assembly process. So, where we use a special purpose machine. Okay. This manual is done by a human being. So, you can try to do parts up to 5 and the total annual production volume is 100. When it is 2 or 1 or 2 robotic arms up to 200 annual production volume, you can do that. When it is 500, you go for this. When it is more than that, you go for this. And please do not go by these numbers. These numbers are just to give you a feel that what happens as and when the number of parts increases and what happens when the production rate increases, how does it go, right. This 100, 200, 500 are not a sanctity numbers, these are just for your understanding. So, some of the guidelines we will start discussing. When we talk about manual assembly, ensure good products accessibility as well as visibility. So, product accessibility and visibility. So, what are we trying to do is you have a human, then he has a left hand and a right hand. So, what you do is you try to keep the parts in a distance such that he can go pick it up and start putting it in this assembly. This is a part. These are trays. So, he picks it up and then he puts it here, right. So, the product has to be accessible within his limits while he is sitting in a sitting posture or a standing posture. He should not extend the full arm to pick the product. And second thing is the product should be placed in a tray or a container where it is clearly distinct. For example, they use a container which is yellow in color and the parts, this is a tray and the parts are black, the parts are black in color. So, this is a contrast difference, or they have a red tray, in the red tray they put the black parts. So, the parts are black, so it is visible, and the second thing is it is also accessible. And then what we do is it is also made sure when you put a tray, you incline and keep the tray such that by gravity the parts keep moving down. So, the operator need not go to the extreme end, stretch his arm so much. Generally, the cycle time will be in 2 minutes, 3 minutes. So, in a shift close to 100 times the operator has to move his left and right arm. So, which is going to be too expensive in terms of fatigue. So, the operator will not be able to work at his efficiency. Second thing is eliminate the need for assembly tools or special gauges by designing individual components to be self-aligning and self-locating. Okay. So, self-aligning and self-locating we have given. So, that means to say when there is a slot there, I drop a part, the part has to get oriented itself, aligned itself and exactly locates at the point where it has to be placed. We can always use another option of drop it anywhere in the part and use some small vibration, the part moves and gets locked out of its own. So, eliminate the need for assembly tools, right, rather than eliminate the assembly tools, try to do it by gravity itself. Minimize the total number of individual parts if possible. For example, if there are 20 parts and this 20 parts, for example, take one part, take a screw and then you have a nut, you have to fix a nut to it and then this assembly gets into the product. Rather than doing it, try to make the nut and the screw as an integral part. So, 2 parts is reduced into 1, and if you can reduce the number of parts, it is well and good. But still if you are forced to do it, now try to assemble 2 parts and instead of having individual parts, try to make sub-assemblies so that these sub-assemblies can be exactly located at those parts and it can at those positions and you can make the part. To facilitate this objective, multi-purpose component may be used. Multi-purpose component, a single component which can do multiple jobs. For example, you can use a part for fastening as well as the same part to reinforce strength to it. Possible, you can do that. Then eliminate excess parts and combine 2 or more parts into one if functionally possible. This is what I was trying to explain in the second point. Also, this is getting told here. So, here in second part we were talking about self-aligning and self-locating and individual parts. So, here they have said that individual parts make sub-assembly, sub-assembly, assembly. Avoid or minimize the number of orient the parts during assembly process. Ensure that all the insertion process is simple and it is unidirectional. For example, you can always do the assembly of a part in vertical face like what happens in a car. But when there are more number of parts and the parts are very small and it is manual assembly, we always prefer to have a horizontal type of assembly. For example, we place the product horizontal and then start putting all the parts in the product to get the final part. So, assembly is done in the horizontal way and in single direction. When we talk about automatic assembly line, the first guidelines is avoid the possibility of parts tangling, nesting and shingling during the feed. For example, when we try to feed, it is said as automatic assembly. So, when you try to do automatic assembly, you are replacing the man. So, when you replace the man, the parts which is there in the tray which I was talking to you now has to come through a chute or a conveyor. So, it has to be continuously fed. When you are continuously feeding it, a individual man cannot drop one after the other after the other. So, what we do is we drop the entire parts, maybe few hundreds or few thousands in a hopper, and then from that hopper through the chute the parts keep moving. So, that is what we say, when the parts move, it should not get tangled, it should not get nested. What is tangling and nesting? Locking with one another is tangling and nesting, right. So, once it tangles, then it becomes very difficult, the part will not flow, the assembly line will stop. So, now what you do is you try to make sure in the design itself such that the parts do not get locked. For example, you can have a spring like this or a washer like this. When you have a washer like this, what happens? These are start point, these are end points. So, there is a possibility the entangling can happen here. So, now what they suggest is please make a washer like this. So, when you make it like this, so this part touches the top of this part or this side of the face is touched at the bottom of this face. So, when it overlaps, it makes sure that entangling cannot happen. So, these are some of the design changes which are made in the washer itself when we use it for automatic assembly. Avoid reorienting assemblies. As such moves many require a separate workstation or machines, thereby increasing the cost. So, reorientation of assembly. Part of the assembly is done. So, then you try to do another part of the assembly in another direction, then in the third direction. Please try to avoid it. Design parts to ease automation by presenting or admitting parts to the assembly machines in the right orientation after the minimum possible time from the feeder. So, once the part drops from the feeder, let your assembly start immediately. The design parts with a low center of gravity, thereby imparting in them a natural tendency to be fed is required. So, try to make the center of gravity as low as possible, so it is stable and it exactly feeds on the location where it is to be fed and the assembly starts. When we talk about robotic assembly, many robo manipulators have poor repeatability. See, robo manipulator is nothing but your hand. You have three orientations. One is pitch, yaw and roll, right. Our hand has lot of repeatability, reliability and sensitivity. That is our human hand, because it has multiple sensors and every link is individually controlled by muscles. But when you try to mimic a human arm and try to make it in the form of a robo manipulator, the repeatability is always a question. Repeatability means to the exact location what it did the first time, the second time and the fifth time and the nth time it has to go to the same location. That is very difficult because it is attached to a series of motors. Okay. So, poor repeatability is a known advantage or a disadvantage of robotic assembly. So, knowing this, you have to do a controller or you have to add a controller and systematically fine tune the error whatever it is done. So, every time it has to be calibrated, check with the calibrated status and then you give the error signal. So, it goes back to the original location. So, poor repeatability, therefore, the features such as lip, leads and chamfer assembly assume a great deal of importance. That means to say, rather than having a sharp edge, you try to have something like a rounded off edge So, you see here rounding happening here, rounding and then chamfer happening here. So, all these things are given such that it exactly goes and locates very easily. So, the part design has to be changed, right. The design components such that all can be gripped and inserted using the same gripper. So, this portion has to be, or the diameter has to be uniform for almost all parts, so that the gripper can easily hold and drop. So, methods for evaluating design for assembly. Some of the evaluation methods for assembly are the Hitachi assembly evaluation method, which is from Japan, Lucas DFA design for assembly method, and method based on method time measurement standards, which is nothing but MTM. So, there are several evaluation techniques. In this course, we are discussing only three which are very prominently used in industries. So, Hitachi assemblability evaluation method. It has three blocks. So, this is product, design, step. Okay. So, here what we do is we preparing product concept, drawing, including ones for automatic assembly. This is done in the product design step. Then making of prototype, then we prepare part drawing, prepare product design drawing, and the last one is receiving samples. Okay. The next assemblability evaluation, what we do is here we see the degree of difficulty of assembly operation. Next, we put scores. Assemblability evaluation score is done. Then we will have approximate assembly cost. So, this is assembled evaluation, and then what we do is we try to compare comparisons. So, we try to compare what and what? Compare, okay, comparisons of various concept designs. This is after evaluation. Then what you do is you look for alternative solutions, right? Then comparison with other company products then what we do is we look for product assemblability ranking. So, first is identify points to improve, then it is eliminate or estimate the effect of improvement, effects of improvement. Then the last point we will have facilitate design improvement. Okay. And this process is an iterative process. It goes like this. Design improvement. So, this is how the Hitachi assemblability evaluation method is done. First, we look at the product design step, then we look at assemblability evaluation, then we look at comparison. Comparison, we not only look at within the part, within the product, what is that? We also look at a similar product, whatever is there, or a similar way of fastening, is there anything else, and compare it with that, do our ranking, and then go back and reiterate our product design step, and then keep moving back and forth. It is very tedious job, and it involves lot of time and skill. So, you have to not only look at within your product, you also have to look comparing with other products within the product and a similar one across the market, and then try to pick up the best one. So, it is always something like benchmarking. You have done something, you have ranked something, like you have ranked 10 points in this is critical, this is critical. Then after the ranking, you look at similar assembly wherever it is happening in the same product, in the business. Then after, you have to also slightly expand your horizon and look at, can this, how is it done in other materials? For example, plastic it is done, how is it done in ceramics, how it is done in metals, all those things, and how is it done in other industries. From aero you have to see in auto you have to see in commercially available or domestic. So, that is how you compare and reiterate, re-improve your design and go further. The procedure, when you talk about Lucas DFA evaluation method, the procedure follows the steps below. First, the product design specification, then product analysis, functional analysis. Functional analysis, first Lucas analysis, loop back to step 2, product analysis. From functional it goes to product. So, it goes back and forth. If the analysis yields problem, then feeding analysis, then you have fitting analysis, then assessment, then return to step 2 if the analysis identifies a problem. So, this is how product design in Lucas happens. Product design specification, which comes from customer voice. I had an interesting question from a student who is undergoing this course. He said, sir, rather than calling it as customer voice, can we call it as customer noise? So, I thought, okay. So, this is product design specification, then product analysis, then what comes is functional analysis. Then you do manufacturing analysis, then this gets split into handling analysis. How are you going to handle the part? And then it is going to be automatic or automation analysis. Okay. Then we have fitting analysis. This goes fitting analysis, and then this goes into insertion fixing, and then we have results. Okay. So, we have output coming from results from here, which goes into product design, then from manufacturing, which also links to it, then from after manufacturing, I can put like this, the same line goes here and here, or I can replace this drawing, I can make it like this and this. So, where you can have H analysis and automation analysis. You can do like this, or the 2 points connect here. So, This is nothing but Lucas DFA evaluation analysis. First will be product design specification, product analysis, then we do functional analysis. Product analysis, how is the product performing, how are the functions performing, functions performing not of the entire product but individual parts in the product. Then how is it getting manufactured, what is the manufactured ease. Then we can talk about handling, and then we can also talk about automation. We can talk about handling, moving the part, automation, inserting, then fixing, inserting, and then results. So this is Lucas design for assembly evaluation method. The method based on method time measurement standards. The various factors are taken into consideration in n improved methodologies such as weight, size, shape of the components being assembled, frequency of assembling task based on the number of similar products being assembled within a particular time frame, personal requirement, postural requirement, material handling requirement, need for component preparation. So all these things are evaluated. First it is recorded, and then what they do is they try to split up into small events, and then they try to accommodate all sorts of events, and for each event they try to calculate the cycle time, and with that the method time measurement is done, and this is also an evaluation method for design for assembly. So you can look at it. So this is method based on method time measurement standards, method of time calculation, stopwatch time study. This reproducibility method description is 50%, then unique method time relationship 50%, advanced planning of method and time is 50%, internationally recognized time standard, it is not suitable for this, it is not suitable at all. So you can say video recording, producible method description, it is good, it is very well suited, and this process video recording for unique method time relationship it is 75%, then advanced planning for method study it can be used as 25%, and international recognized time standard it has poor suitability. So this will try to tell different ways in which the measurements are calculated: stopwatch study, activity sampling, self recording, that means to say on the helmet you can have a camera, then compare and estimate, video recording, standard data which is available in the books, then MTM study, method time measurement study. Here it tries to give good reproducibility, time relationship it is very good, advanced planning and methods it can help, and it is internationally recognized as a time standard. So this is what is the design for assembly, another technique which we are using. So we would stop here, we will continue in the next class. Thank you very much.